In the end of the chapter 5, we have now light. The solutions of the Parasian wave equation is in proportion to the h function. And we all know that h function is the impulse response of the diffraction system. But if you carefully to observe the form of the h function shown here, you will see that at z is 0 at the origin. Due to we have the z here, at z is 0, the h function will go to infinity. Okay, this will form a singularity at the origin. What I am saying is that due to we have the z here, we will have a delta source at origin. But this is not satisfy the physical meaning. This is physically unreasonable. So we have to move the singularity out from the origin. To do that, we re-express the impulse response h in this form. As a result, the h function will become like this. And clearly, by doing so, you can see that we will no more have singularity at origin. But still, if this term is 0, we will also have the h function goes to infinity. That is, there still exists a singularity at another point. Which point? At z is z0. So if you just doing so, you just move the singularity from the origin to another point here. This will not solve our problem. And then some guy comes to a very genius trick. Mathematically, we can let z0 to be expressed as minus jb, in which the b should be a real number. The reason b must be a real number is that if b is a real number, then z0 will be a pure imaginary, okay? So this condition also means that z0 must be a pure imaginary. As we set the z0 to be in this form, we can move the singularity to the point. Which point? To the point z is z is jb and z0 is jb, so you can see then the z0 will be a pure imaginary. So this means that the singularity will be moved to the imaginary axis. By doing so, we can move the singularity to the imaginary axis. The singularity will no more appear on the real axis. So we can rewrite the h function in this form. U sub 00 x y z. The 00 here will be explained later, and it will be in proportion to lambda times z plus jb in here, and here is j times exponential, the following term. So this one is the solution to the Parseval wave equation. And as I have said, this one will not have a singularity in the real axis. Okay, the singularity has been moved to the imaginary axis. So this form will be our solution. We will discuss later, and by doing that, we have to normalize the power of the solution. So we can normalize here. We just say the U00 is in proportion to this form, right? So we have to use the power normalization to clearly express the U00 function. What's the power normalization? The power normalization is that we let the total power of each solution, the total power carried by each solution, is 1. So if you have specified the total power carried by each solution, then you can clearly express the form of the U00. And what will be that form, we will discuss in the following slide.